All right, welcome back to part 2. Here we're going to go over question 11 through 20, but I really quickly wanted to go back over number 10 because I know in my last video I got cut off because my time ran out. But I wanted to just make sure everyone understood that a y-intercept, because it crosses the y-axis, its coordinate is always going to be 0 and then whatever your y-intercept is. And so because of that, whatever your y-intercept is, that's going to be 0.0b. So because our y-intercept's -5, then our answer is going to be C, 0, -5. All right, let's take a look at the next problem. We are going to at this graph, and we have to find, because this line does not go through our y-intercept very clearly, it's hard to tell what this spot right here is. I'm going to end up using our 2 points instead. All right. So we're going to use the points that are here. So I'm going to use this point right here, which is -4, +4. Okay, if I'm looking at its point on my graph. And then I'm going to use this point down here, which is 5, +1. And I'm going to use those to help me find my slope. Now I can use the slope formula, y2 minus y1 over x2 minus x1. So I can use this formula to do that by taking my x1, y1, and it does not matter which point you make x1, y1, or x2, y2, as long as you are staying consistent. You want to make sure that if I take the y from one point, that my x from that same point ends up being right underneath it, okay? And then over here I would have y2 and x2. And as you can see with my color coding, this on this side we have 1 point, and then on the other side we're going to have a different point. Okay, this is over here. And this one's over here. And as long as those points stay like ratios, then you are fine. So you're going to go ahead and subtract, and you're going to get 4 take away 1 is 3. -4 take away 5 is -9. So my slope, or m, is -1/3. Now, another way that we could do this, if you really were looking at your graph here, ooh, that's too thin. Let's pick something else. Let's do a highlighter. I could take the rise and run from these points here. So I could look here, and I could look all the way over to this point, and I could count my rise and run. So if I do that, because these are going by ones, I would get 1, 2, 3 as my rise. As you can see, that's the same thing here. And if I count down here, you're going to get 1, 2, 3, 4, 5, 6, 7, 8, 9. This is a 9. Okay, the reason I know it's negative is because the slope of my line is going down from left to right. So those are 2 different ways to find slope. Once I find my slope, I then have to plug it into my equation. So let's try to do it over here. I'm going to have my y equals mx plus b. I know that y, I'm just going to pick one of the points. So let's just pick the yellow point over there. Y is going to be 1. And then my slope is -1/3. And I'm going to make x5 plus b. So again, so that you can see where it's coming from, these numbers, the 5 and the 1 are from the yellow point that's over here. Okay, my x and my y. I am then going to solve by saying, okay, now 1 equals, if you don't know how to multiply those fractions, you're just doing -1/3 times 5 over 1. Okay, that's why I'm going to get 5 over 3 negative. -5/3 plus b. And then I'm going to go ahead and add 5/3 to both sides. Okay, 1 whole is the same as 3/3. Oopsies. Sorry for the glitching. And so 3/3 plus 5/3 is 8/3. That's going to make b. okay? And that is why the letter B is our answer, because my y-intercept here and my slope is the same. In number 12, we are reading the graph. So the graph below shows the balance of students' lunch money account. So we've got the account balance on our Y and the number of lunches on our X. We want to know which ones are true. Select all that apply. There's more than one right answer. Each lunch costs $4, or does each lunch cost $5? I'm going to look at my slope. So I'm going to find another point on my line, like this one right here, and I'm going to go ahead and count my rise and run. You could also do your slope formula if you wanted to pick the points here. But for me, I think this is a little bit easier. If you notice, you're going by twos, 2, 4, 6. So therefore, this number right here is 20 or 32. And then this number here is going to be 40. The difference between 32 and 40 is 8. So that's my rise. And then down here, I'm looking at a run of 2. 8 divided by 2 is 4. It is a negative slope as it goes down from left to right. So my slope is -4 because I'm spending $4. So each lunch costs $4. The account started with a balance of 40. This statement can be proven by looking here at the initial value, okay, which was 40. Right here. Whoop. Okay, so that one is also true. The student won't have any money left after eating 8 lunches. Well, we can see right here at 8, if I follow up, I still have money here, about $8. Okay, and if each lunch costs 4, we know that they can buy at least 2 more lunches, so that's not true. And then the last would be that they have enough money in their account to pay for 40 lunches. If I were to continue my line after 40, I am not going to have enough for 40. I barely have enough for 8. So this is also not true. So my 2 answers are F and H. All right, this problem right here can be slightly tricky. Oops, sorry. It's just got a lot of steps to it, and because we have our fractions, that makes it a little bit more difficult. But we're going to go over here and do the same thing that we did to a previous problem, where we're still going to just basically plug it into that slope-intercept form after we find our slope. So in order to find our slope, I need to label one of my points as 1, one of my points as 2, and then I'm going to subtract. So we're going to do 8, take away 5, that's my y's, -1/2, take away 3/2, that's my x's, and I'm going to get 3 on top. Okay, just subtracting just like I would straight across like a regular fraction. I just happen to have a fraction within a fraction. Then I'm going to do -1/2, take away 3/2, and that's going to get me -4/2, which is the same as -2. So I know that my slope is -3/2, so I can look at A and B and immediately cancel those guys out because their slopes are not negative. So my options are going to be C or D. So I am going to then go ahead and look for my y-intercept. So we're going to do that over here on this side. We'll do it in blue. So for my y-intercept, I'm going to take that same equation, and except this time I'm going to replace x and y. So let's just go ahead, I don't know, let's use this one. It does not matter which point you use, just as long as you're picking a point. I'm going to use 8 for y. My slope is -3/2, and I'm going to times that by -1/2. And I'm going to add that b. The b is what we don't know, okay? Once I solve this right here, so when I multiply these numbers here, I'm going to end up with 8 equals -3 times -1 is a +3. 2 times 2 is 4, plus b. When I subtract 3/4 from both sides, I'm going to get 7 1/4 equals b. So if my equation was a normal equation and it didn't have any of this interesting kind of distributive property stuff going on in it, I would have y equals -3/2x plus 7 1/4. Okay, but that's not what I have here. So what I have to do is actually distribute out these slopes to figure out which one would be correct. Okay, let's just take the bottom one here. So if I distribute this out, I'm going to get -3/2x. Again, I'm doing this problem right here. And I'm going to add, because negative 3/2 times negative 3/2 is going to give me a positive 9/4. Okay, plus 5. If I add these two things together, I end up getting 7 1/4. And that's what I'm looking for right there, is that y-intercept. So D is our correct answer. If you do the top one, you end up not getting 7 1/4. And so that is why C is not our answer. For number 14, we're going to go ahead and look at these equations here. We have the slope of 1/2, and it goes through this point. And if you notice, I have two equations in point slope form. I have two equations in slope intercept form. And then I have two equations in standard form. And I need to figure out what equations. I'm going to probably pick one of each. So let me work this out for you. All right, so this is a lot of work here, but as you can see over here, I've got y equals mx plus b. That's slope intercept form. I have point slope form laid out over here. Y minus y1 equals m times quantity x minus x1. And over here I have the standard form, ax plus by equals c. When I work out my problem, so again, I'm super familiar with slope-intercept form, so I'm going to go ahead and plug it into that first. So I took my points, -6 for x and 2 for y, and I plugged them into my equation. I solved, and I got that b, my y-intercept was 5. That automatically shows me that that right there is my slope-intercept form equation. From there, I am then going to turn it into a point slope equation and a standard form equation. So with point slope, it's basically the same thing. I know my slope is 1/2, and then I'm just going to take the points, x and y over here, and I'm going to plug them into my equation. It can't be this one up here because here they used the x value for y and the y value for x. Then I went ahead and I took my slope intercept form and I turned it into my standard form, just like we did in our warm-ups. When I did that, I ended up getting J. So G, I, and J for that one. All right, in our next two equations, or next two problems here, we have the coordinates for the y-intercept for standard form. So if you remember correctly, in standard form, that is x is the x-intercept and y is the y-intercept. So if I get rid of the y-intercept by turning y into 0, then I am going to get just the x-intercept by itself, and when I solve that, I get 4. So my x-intercept is going to be 4, 0. Down here, we've got a teacher has $75 to spend on paint sets and marker sets. Paint sets cost $3.75 each, and marker sets cost $1.25 each. What's the greatest number of marker sets that the teacher can purchase? So I made markers equal x and paint equal y. I set up a standard form equation, where if I buy markers and paint sets for the prices they're given, it makes $75. If I turn my paint sets into 0, just like I did in the previous problem, I can get rid of them and then just divide 75 by $1.25, which is 60, and that's the answer there. All right, in number 17, we are comparing two different functions. So you can see here that I just counted rise over run. You can also pick 2 points and use the slope formula to find your slope. The slope of line A is 4. And line B, I had to rearrange my standard form equation into slope-intercept form equation so I could find my slope. I did that and found that the slope is 3. 4 is greater than 3, therefore line A has a larger value for slope. Number 18, we're comparing two functions again. So this one has 2 points, and I did that on the left here. And the second function is here on the right. On the left, I went ahead and just found slope first to compare. On the right, I rearranged the equation so that I could find slope. The right function is a larger slope with 4 over 3. And then I identified its y-intercept here as -2. All right, number 19, we're looking at two lines that are perpendicular to each other. And if you remember, that means that they're inverse opposites, so upside down and the opposite sign. I'm going to take these 2 points to find slope using the slope formula. The slope of line W is -5 over 8. If I do the inverse of that, that's +8 over 5. And number 20, we are looking for a parallel line. It means it has the same slope, so A is the only one with the same slope.